Alright, so we're going to continue with triangle congruence. So one way to show that two triangles are congruent is to show that every corresponding part is congruent. Sometimes there's not enough information to show that, and also it could take forever because you're talking about 6 different sets of parts. So it turns out there are some shortcuts. There are 5 shortcuts that can be used instead. You've got side, 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 angle, side, angle, 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 side, side, angle, side, and hypotenuse leg. These shortcuts are called postulates. So instead of proving all 6 parts are congruent, you're going to be proving that 2, in one case, or 3 parts are congruent to each other, and that's enough to show that the entire set of triangles are congruent to each other. So starting with side, side, side. If 3 sides of a triangle, let me back out, if 3 sides of a triangle are congruent to 3 sides of another triangle, then the 2 triangles are congruent. So what it would look like is something like this, where you have congruence marks that show that side AB is congruent to side XY, side BC is congruent to side YZ, and side AC is congruent to side XZ. So that would mean that triangle ABC is congruent to XYZ by side, side, side. Now, sometimes side, side, side is not that obvious. So, for example, you may be given a picture like this. And you're given that point B is the midpoint of line AC. And that's all you're given. That's all you're told. And you're shown this picture, and you have to show that the 2 triangles are congruent. Well, we know that side AD is congruent to side DC because it's given with the congruence marks. Side BD is congruent to side BD. Well, it's the exact same line. So the reflexive property math says that anything is congruent to itself. And side AB is congruent to side BC. So if B is the midpoint of side AC, so that's the middle of it. So that means that part AB and part BC have to be equal to each other because B is right in the middle. It's the definition of midpoint. So once we have 1, 2, 3 sides that are congruent, side, 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 then we can say that triangle ABD is congruent to triangle CBD because all of the sides are congruent. So they are congruent by side, side, side. The next shortcut or postulate that we're going to look at is angle, side, angle, or ASA. So it reads that if 2 angles in the included side of one triangle are congruent to 2 angles in the included side of a second triangle, then the 2 triangles are congruent. So that looks something like this. The included side, what included means is the side between the 2. So this side is between the 2 angles, so it is included between the angles. Just like side, 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 sometimes angle, side, angle is not as obvious either. So you're given this picture. You're told that E is the midpoint of AC, and we need to show that the 2 triangles are congruent to each other. Well, the first thing we can write is that angle A and angle C are congruent because of the congruence marks that are shown in the picture. Segment AE is congruent to segment EC, those sides of the triangles. They are congruent because E is the midpoint. The 2 segments are congruent, so that's the definition of midpoint. Angle AEB, so this angle right here, is congruent to CED, which is this angle right there. We can't just say angle E because it represents 2 different angles. But it's the 2 angles are vertical, so that means that they're congruent. And because the angles are on each end of the corresponding segments, we have an angle, a side, and an angle. Over here are angle, side, angle. The triangles are congruent by ASA. The next one is angle, angle, side. If two angles in the non-included side of one triangle are congruent to two angles in the corresponding non-included side of the second triangle, then the two triangles are congruent. So if you've got two angles and the corresponding sides, then it's congruent. And it looks like this. So it's not included. So the included side would be over here. This one's not included. Angle, angle, side. There are more complex versions of angle, angle, side, looking at a picture like this one where we've got some parallel lines. So AB is parallel to DC, and that's given right here, and it wants you to show the two triangles are congruent to each other. Well, angle C is congruent to angle A, or A is congruent to C, it's given by the marks. And then angle ABD, that's this top angle B up here, is congruent to CDB, which is this angle down here. If you think of this as two parallel lines and the transversal that cuts between them, then what we have is alternate interior angles. And alternate interior angles are congruent to each other. So I know that this angle is congruent to that one. And again, DB is congruent to DB. Anything that is itself is congruent to itself. So I have an angle, and a side. And here I have an angle, and a side. So these two triangles are congruent by AAS, angle, angle, side. Number 4, side, angle, side, or SAS. If two sides in the included angle, so where before we had two angles in the included side, now we're talking about two sides in the included angle. So if two sides in the included angle of one triangle are congruent to two sides in the included angle of the second triangle, then the two triangles are congruent. So here we've got side, angle, side, side, angle, side. The angle is included between the two sides. So a more complicated version of side, angle, side, given that D is the midpoint of AC. So we'll start with the side BD is congruent to BD. Anything in math is congruent to itself. It's reflexive property. Alright, angle ADB and CDB. Well, it's shown here that little mark means that that's a 90-degree angle. These two angles are side by side on a straight line, which makes them a linear pair. So I know that angle CDB, which is over here, plus ADB, which is over here, has to add up to equal 180 degrees. Well, since ADB equals 90, I can replace it. When I subtract 90 from both sides, CDB also equals 90. If they both equal 90, then the two angles are congruent to each other. That's the definition of congruence, two things that equal the same. And last, AD is congruent to DC. Since D is the midpoint of AC, the two segments are congruent to each other. So the two triangles are congruent because two sides and an included angle are congruent, making them congruent by side, angle, side. Side, angle, side. Last but not least, HL, which means hypotenuse leg. If the hypotenuse and the leg of a right triangle are congruent to the hypotenuse and leg of a second right triangle, then the two triangles are congruent. So if and only if it is a right triangle, you can have angle, side, side. Otherwise, we don't have ASS in math class. Angle, side, side does not exist. Right angle, hypotenuse, leg exists. And those two triangles are congruent if a hypotenuse and a corresponding leg are congruent. Thanks.